Hey guys, what's up? Welcome back to the channel, and today we'll be creating a decentralized application to send messages to another user, which will be end-to-end encrypted and totally secret messages. And we will also be creating the smart contracts and as well as the front end to create a whole packaged Web3 application. So let's see how we can do that. Okay, we will start with creating the smart contract. So for now, we will be using Remix. We can use other frameworks like Hardhat and Truffle, but to make it simple, we will be creating our contract using Remix, and we are going to use the Cloud Remix editor, but we will be editing our local files using the browser. So to do that, just go to Google and search Remix IDE, and you will go to remixproject.org and scroll down. You will see Remix D. Open that up. It will tell you how to install Remix or Remix daemon. So once you copy this installation command, open up a terminal and just paste the command. So you have to have Node.js and npm installed. So I already have Node.js installed, so I'm assuming you have Node.js installed. So once you have Remixed installed, go back to the website and use the Remix Online IDE. Just accept it and it will open up in your browser. Yeah. So it will open up with the default workspace, but what we want, why we want to use our local folder. So for that, we'll connect to localhost. So before you connect to the localhost, you have to have Remixed running. So go to a folder where you want your scripts or your contracts to be saved. For me, it is repos, YouTube projects. We go to this. Let's create a folder here. Okay, dir, and we are going to call this project dmail because decentralized mail. Why not? Now go to dmail. Inside this, we're going to create a folder called contracts, and let's go there, and we are going to initialize our remix daemon here. So remix d. Once you have run remixed daemon, it will show up like this, and it will be running on port number 6550220, and you can go back to your browser and click on connect to localhost. Click on connect. Yes, now this folder is the same as the folder that we created using the command line, and this is the folder. And if I create a new file here called dmail.sol, here we can create our Ethereum contracts. I have a shortcut for here. What you can do, go to the default workspace, get one contract, copy the initial part, and I think that's it. We'll name our contract dmail, and we'll call it, you can remove these parts, not required. We'll give the title as dmail. You can change the license to whatever you want. I think MIT for me is fine. We need few things. One is, when we send a mail, we need to store the mail in a mail ID, which will be the counter. When there is a new mail, it will increase the counter and give that ID to that new mail. Okay, so we need a counter to keep track of mail ID. So we'll call it mail ID, and it will be an unsigned integer. So in Solidity, we have uint 256. This will create an unsigned integer, long enough to have all the mails in the universe. Mail ID, and we need to keep track of which user stores which like whoever the senders and receivers of the mail, and what are the mail IDs that users has sent or received. So for that we will create a mapping, mails by, it will be like mapping, and we will use the wallet address to identify the user. So address, and it will give us the list of mail IDs that the user has received. Unsigned in a 256, and it will be an array, and we'll call it mail received. Okay, now we will need another mapping for the sent. And now we will need another mapping to get the mail content from the ID. Mail content by ID. So it will be another mapping, and this time it will be from the ID, which is unsigned integer, to content, which will be a string. Mail content. Okay, now what we want to do here is whenever users comes to our application, we want the user to have register with our application. So to do that, we'll create a profile struct, and this profile will hold the address as an ID of the profile. And whenever we want to send mail or encrypted message to the user or another user, we have to know their the public key. We have to encrypt the message with their public key, and they will be able to decrypt the message with their private key. That is the whole concept of the end-to-end encryption. So to have to send a mail to that person, we have to know their public key first. So whenever the user registers, they will save their public key in our contract, so the other user can add and get those public keys from the contract. So we'll have a public key variable, and we will have a profile mapping, which will give the profile detail from the address. Okay, so we have most of the variables ready, and we just need some functions to execute from our front end. Now what we want whenever there is a mail sent or any message sent from one user to another, we want an event to be emitted, so that all the mail client, all the front end will get notified that the mail received or mail has been sent. So we'll create an event, mail sent event, and we'll call it sent event, and it will have an argument of address, and we want this these parameters to be filtered. So that means whenever these events are sent, we want the control from the front end that which event we want to look for. We want to get notified if the sender is this person, if the receiver is this person, or blah blah blah. So for that we want this parameters to be indexed, otherwise we will not be able to filter based on these criteria. So this will be indexed, and this is from, Another parameter we want is the to address, and we also want the mail ID to be indexed. After that, we can have another variable or value, which is the encrypted value of the mail. We only be able to use 3 parameters as an index. We will not be able to use more than 3 if the event is not anonymous. So for that, we will not be indexing the value. So this is the ID of the mail, and this is the value, which is with the message that has been sent. This is basically the encrypted message. So only the user who has the private key will be able to decrypt this message. So in the contract, we will be sending the encrypt. We will be saving the encrypted message in these variables. Now we have all the events and all. We don't need any more events. What we need is a few functions to send and receive mails. To send mail, we will have, let's have some doc string. Function send, and we need the address of the sender or the receiver. So it will be the to address, and we will need the value or the message content. This is a public message or a public function, anyone can call this, and this will not be a view only function. This will change the contract data because we are sending the message, so it will be stored in the contract. What we want to store this value to the mail content, and we want the newly created mail ID. This will store the message with a new created mail ID or mail whatever the current mail ID, and it will store it in this mapping with this ID. And we will be also pushing this mail ID to all the receiver senders mapping. Mail received, this mail ID. So this will be mail received will be whatever the to value is. It will be dot push, because this is an array of IDs. We have to use dot push to add a new entity, mail ID, and same goes for the send, but this time it will be mail sent, and instead of to, it will be message dot sender and push to mail ID. Okay, once we have all the variables set, that means the mail is sent, and we are going to emit this event. So the from address for that is the sender message.sender. The to address will be _to, and the ID of the mail will be mail ID, and the value is value. So this is the mail event that we have created earlier, and we are just calling this event, passing the variables or parameters. Whoever wants to subscribe to this event will get these values automatically, and after we are done, we are going to increment the mail ID. Mail ID equals mail ID plus 1, and that's it. We have sent the mail. Let me just copy this, and we'll have, so whenever our user registered with our application or with our app, that person needs to registered their public ID with the contract, otherwise we will not be able to send a encrypted mail to that user. So to do that, we have to have a function which will save the public ID or create the profile for that user. So what we will do, we will create set key, and we will call it set the key of user, and we will need the key only. Other than, we don't need anything other than that, so we'll remove this and we will call it KUI. We don't need anything here. Profiles, and in the profiles we'll have message.sender address, and this is the mapping that we created earlier, which will, if you supply the address, it will give you the profile. Now we will create the profile, which will have sender, and it will also have the public key. This way we will always have the public key of that user. Now we need some functions to get all these values that we want to share to the share to the other users publicly. For that we will need some get functions. We need one to get the public key of a user, one to get the received message, one to get the sent messages, and one to get the mail content. So what I will do, I will create these get functions and I'll share it, and we will just put it here. So these are like after the set key we have the get key, we have get received mails, which is just returning the sender's received mail, get sent, and get mail, which will, if you supply the mail ID, it will give you the mail content. Okay, so we have our contract ready. We now want to compile this contract. We have some errors. It is in sent event, identifier not found, not unique. Okay, let's go to the event, and identifier not found and not unique. Okay, we have address, indexed, IMDXD, address, index 2. Okay, so this is unsigned integer uint. There was a typo there. Other than that, this will be okay, this will be 1 instead of I, and we have another is at line number 53. Oh, this is public KUI key. I think that's all. Let's compile it. Okay, so we have compiled the script, and we want to deploy the script in our let's try it with Polygon testnet. Okay, let me open up it. Okay, I have this development account ready, and I can use this tab and to connect to the MetaMask, which is injected provider MetaMask. It will ask you to connect. Let's connect. Okay, now Remix is connected, and we want to use this one. Okay, that's fine. This is the contract that I want to deploy. Let's deploy the contract. It will ask for confirmation, confirmed. It will take some time to deploy. Okay, so we have our contract deployed. Let's now come to the front end. Thanks for watching, guys. Please like and subscribe, and you can get the next video of the series somewhere around here or here.